Welcome to today's lesson. I'm Siamasaka Kirian-Dins, and so today I'm going to take you through a lesson in chemistry. Basically, we'll look at O level and we'll look at relative atomic mass as well as relative molecular mass. We'll look at their meanings and how to calculate them. And so we go straight into the lesson for today. And so we note that today, as I indicated earlier, we are basically looking at relative atomic mass of an element. And basically, what it means when you say we need to find the relative atomic mass of an element, we are merely looking at the standard comparable element. And so initially, they actually chose the relative atomic mass of the carbon atom, which is carbon 12. And so all other elements were compared to this specific carbon atom. And therefore, the definition of relative atomic mass is it's actually the average mass of its atoms compared to 1/12 the mass of carbon 12 atom, or it is actually the relative atomic mass of an element. And by looking at its average weight of the masses of its isotopes on a scale on which carbon atom has been placed with exactly actually 12 units. So this is actually what relative atomic mass is. In simple terms, we are saying if there are isotopes are atoms of the same element with a different mass numbers. So you add this and you get the average. And therefore, then you compare actually with that's the ratio with the atom of carbon 12. And so basically that's actually relative atomic mass. It is basically the average mass of atoms compared to 1/12 the mass of carbon 12 atom. And so here we are going to say again, the relative atomic mass of an element is the weight in grams of the number of atoms of the element contained in 12 grams of carbon 12. And so this relative atomic mass actually is written in, its symbol is actually capital A and R. So this is actually relative atomic mass. Atomic mass. And it has no units actually. It has no units, so we have said here, the relative atomic mass is dimensionless, meaning that actually the relative atomic mass has no units. It's dimensionless. So this is very important because at times students tend to actually misrepresent it and they'll put units there. So actually it has no units. But the most important is that actually we need to know that each time we are looking at relative atomic mass of an element, we are comparing it to 12 grams of carbon 12. 12 grams of actually carbon 12. And so here we will look at this comparison that we have talked about. For example, now let's look at the relative atomic mass of potassium atom. And so here's the question. Potassium has a mass of 3.26 times greater than carbon atom. Calculate the atomic mass of potassium. And basically, all we need to do to get the relative atomic mass of potassium will multiply how many times it is actually greater multiplied by relative atomic mass of carbon, which we have already we know this is 3.26 multiplied by relative atomic mass of carbon, we say it is carbon-12. And this gives us actually 39.1. And it has no units. So relative atomic mass of potassium is actually 39.1. And so here, because we have said actually potassium has a mass that is 3.26 times greater than that of carbon. So we may multiply how many times is greater multiplied by actually that of carbon, which is comparable, which is 12 carbon actually. And so this is basically what we do. Here's another question. At times, basically, they would not compare. When they ask a question, at times they would have compared with a different element. For example, here, atoms of element T are found to be 2.22 heavier than that of oxygen atoms. Given that the relative atomic mass of oxygen is actually 16, identify the element. And so here, they have not compared to carbon, they have compared to oxygen so that we identify the element T. So in other words, the relative atomic mass of this element T will be equal to 2.2 multiplied by relative atomic mass of oxygen, which gives us 2.2 multiplied by 16, which gives us 35.5. So this is the relative atomic mass of this element T. And if we go to the periodic table, you find that actually the relative atomic mass of an element with 35.5 is actually chlorine. So we can say actually element T is actually chlorine with the actually relative atomic mass of 35.5. So we note that actually we have identified this element T. It is actually chlorine because it has a relative atomic mass of 35.5. And now that we have looked at relative atomic mass and we have done a few calculations, and now we look at relative molecular mass. The relative molecular mass actually of an element is the sum of all relative atomic masses in a molecule. In other words, what we are saying is that we add all the relative atomic masses that are found in a molecule, and then we come up with what is known as the relative molecular mass. It is molecular because it is actually a molecule So in other words, there should be more than one element. So relative molecular mass, we are saying it is actually the addition of all the relative atomic masses in a molecule. And we note that also the relative molecular mass, which is denoted by the symbol MR, it is actually dimensionless. Which means that it has no units. As we saw in the relative atomic mass, which you said it has no units. So similarly, the relative molecular mass has actually no units, and it is denoted by M with a subscript R, denoting that this is the molecular mass. And now we'll go straight and see how we can calculate the relative molecular mass. Here is a question. Calculate the relative molecular mass of nitric acid. So it is very simple. So we started by actually relative molecular mass of nitric acid. This is the formula for nitric acid. Should be equal to, you look at the subscript for hydrogen here, it is 1 multiplied by, you get the relative atomic mass of hydrogen, plus you look at the subscript for nitrogen, it is 1 multiplied by the relative atomic mass of nitrogen. Then you look at the subscript for oxygen, it is actually 3 multiplied by the relative atomic mass for oxygen. And you may now substitute. So you have 1 multiplied by the relative atomic mass for hydrogen is 1 plus 1, the subscript for nitrogen, multiplied by the relative atomic mass for nitrogen is actually 14, plus the subscript for oxygen is 3 multiplied by the relative atomic mass for oxygen, which is 16. And what you get here, 1 times 1 is 1, plus 1 times 14 is 14 actually, plus 3 times 16, which is 48. And so what we get is actually 63. So the relative atomic mass for nitric acid is actually 63. So basically this is what we do. You may, first thing is to identify the subscripts to each element in the compound, and then multiply it with the relative atomic mass, and then you sum all of them. And this is actually how we calculate the relative molecular mass. And you notice that I have not put units here because actually relative molecular mass has no units. And so we can do another question. Calculate the relative molecular mass of glucose. And so relative molecular mass of glucose, carbon 6, hydrogen 12, oxygen 6 would be equal to, you look at the subscript for carbon, which is 6, multiplied by the relative atomic mass of carbon, plus the subscripts for hydrogen is 12, multiplied by the relative atomic mass for hydrogen plus the subscript for oxygen is 6 multiplied by the relative atomic mass for oxygen. And so, you notice that here now, we're going to have 6. The relative atomic mass for carbon is 12 plus 12 multiplied by the relative atomic mass for hydrogen is 1 plus 6 multiplied by the relative atomic mass for oxygen is 16. So what we have is this one gives us actually 72 plus 12 plus 6 multiplied by 6, that is 6 there, that is 96, which gives us actually 180. And so the relative molecular mass for glucose is actually 180. And so this is actually the simplest method of calculating the relative molecular mass. And we have noticed that actually the relative molecular mass has no units. We can do the final question. Calculate the relative molecular mass of sulfuric acid. And so here we have sulfuric acid. So we need to calculate the relative molecular mass for sulfuric acid. We do it by looking at the subscript. This one is 2, so it will be 2 multiplied by the relative atomic mass for hydrogen plus the relative atomic, the subscript for this one is 1 multiplied by the relative atomic mass for sulfur plus the relative atomic mass for oxygen is 4 multiplied by the relative atomic mass for oxygen. And so it gives us 2 multiplied by the relative atomic mass for hydrogen is 1 plus 1 multiplied by 32. The relative atomic mass for sulfur is 32 plus 4 multiplied by the relative atomic mass for oxygen, which is 16. And then what we get 2 times 1 is 2 plus 1 times 32 is 32 plus this is actually 64. And what we get is actually 98. And so the relative molecular mass for sulfuric acid is actually 98. And so I thought this is how we can calculate the relative molecular mass as well as the relative atomic mass. For those who want actually intensive lessons, you can contact me on my WhatsApp number 260-977-4199. And then my email address is K, all small letters, Siamasaka @gmail.com. And so we can actually do one-on-one lessons in chemistry as well as physics, O-level as well as A-level physics for those who are preparing to go for degree programs related to science. And so we can schedule a time when we can actually meet online, and then you pay a small token. And so I hope you can subscribe to my YouTube so that you can receive more of these lessons. And now our next lesson, I'll look at actually the molar mass and even the more concept, and ensure so that you get more of these lessons. Ensure that you subscribe as well as actually contact me. I thank you.